So hi everybody and welcome back to our C++ tutorial series for absolute beginners. This is video 337, and in this video we continue with our move constructor and with the examples. We already talked here a little bit, and in my last video I said you should try to explain this code snippet a little bit more in detail with every step and with the constructors and the value categories. I hope you tried this. And if you made it wrong, no worry, I will make it not perfect too, because there are also compiler optimization and this kind of stuff we will skip. Alright, let's get started. So first of all, what we are doing here, we want to create a variable called A1, but this is our initialization. And that means we are starting not here in the left side, we start here with the right hand side, because we take this one and initialize this right hand side. We take this one and initialize it to the left hand side. So here is our start point, but we are also not starting with the function f here, because the function f here has an argument, and the argument here is a ampersand. So what is this ampersand? This here is actually creating an anonymous object. What is an anonymous object? This is the same thing, almost the same thing like here. Here we try to create a named variable object with A1, and here the difference is just here is no name. So we create also here an object but without a name, and that's why it is called anonymous object. And interesting here is also the difference about the value categories. This one here is a named variable, so this one will be our L value, and here in this case it is anonymous object, and it is just created here temporarily, which means we just create it here and use it no other places at all. We can't use it anyway because we have no name to use it anywhere else. So it is a temporary object, which means it is an R value. So we have here two different kind of creation of an object. So I have marked this here in our first step. Here we create this temporary object. It's an R value. Probably we are using this double ampersand later. So the second step is now this one is passed to the function. So what I mean with that is, here is our function. This is that what we just created, and this one is passed here by value. But the question is now, will be this copied here or will be moved here? And let's go into this. First of all, we have to go to the function. Here is the function. Then we go here to the parameter, because it is passed here to this parameter. And first question, what are we doing here? We are creating here also an object, because we are creating here this local variable A object. Alright, so we are creating an object. This is the same thing what we are trying to do here. Here we created an anonymous object, that was this here. And now we're creating this local A object. But we're creating this one with this passed R value temporary object. What happens now here? And to understand this, we have to go to the type A and check how can he bind this temporary object. So what happens? So you jump here to this A type. A is our struct, and then you can see we have here constructors. And I said before, this one here was a temporary object, an R value, which means we have this double ampersand, and the compiler says, oh, this struct A has defined a move constructor, and I can use it. So the compiler says, nice, I use this move constructor and I will construct this local variable A. And let's write here, we are using the first time the move constructor. And by the way, I talked already about this move constructor in my other videos. Don't get confused with this one here, this double ampersand, because here you can see we expect an R value. This is the first part. This one here, it takes the R value, this says I expect it, but the second part is after I bind it to an named variable, here this O, then I can use it in other places. I treat this one, even if you have a double ampersand R value type, as an L value. And that's why we have to use later here again this std move to convert it back to an R value, so that when we assign S the new value from here, that the strings move constructor is called and not the copy constructor. But we talked already about this a little bit. So here we created our local variable a with the move constructor. That's very important in this case. So let's go to the next step. The next step is actually here in the function body with the return value a. And let's see what happens here. First of all, we have to note after we created this local variable a, this is a named variable. Named variable, again, what is that? An L value, because I can use a in other places, and you can see the a is here created and I use it here. I could use it in a function body elsewhere too, but it is used here. And now we have an L value here. So this one is returning an object which is an L value. All right, so an L value is a problem because L value is all time using the copy constructor. It can't bind, an L value can't bind to the move constructor. Why is this a problem? Because the copy constructor is very slow compared to the move constructor. The move constructor is just flipping one pointer. It's super fast, nanoseconds. But the copy constructor, when we have just one word, it's still very fast. But keep in mind, this S here could be also, let's say, I scan a book with 50 million words. Then we have here 50 million words, let's say 10 million words, and then every 10 million words had 5 characters in average. Then we have here 50 million characters around, and then 50 million characters are around 50 megabytes, and 50 megabytes will take around to copy just by this one here around 5 milliseconds. And when we compare then 5 milliseconds copy vs almost 50 nanoseconds, this is a difference about over 50,000 times. So which means this one is 50,000 times faster than this one. When this S here gets big. This was just an example, but you get the idea. That's why we try to avoid this. But here we have bad luck. This one here, this local variable a, is an L value. Okay, and now what happens here? Here it says I return this local variable, which I created here in the function, back to the function. What means that exactly? In short, it is creating again with this L value a temporary or result object for this function. What in short, we are creating again here, this A is creating again an object, temporary object like we created here, but this time the difference is here it was an R value, here we created with an L value. And let's see what happens there with an L value. Again, when we create a temporary object, you go to the type is A, you check the constructor, L value can't bind here, it must bind here, and we create this one. So here in the second step, we have created it with an L value which is slow. This is very slow. All right, slow. And then we go further after we have finished this one, because this is our temporary result object for this function, which we are returning. And we can make this so this is the result, because this one we have finished now. This one is our result, and this one here we take to initialize our variable a1. That was our goal right here. We try to initialize a1, and how we do this again with this temporary object. So here this one here is again an R value. Why? Because the return value of this function here, like I said before, it is called with an L value, but the result itself is a temporary value, which means the result is an R value, and again unnamed, anonymous, because no name. You can see it's just created the object here, and this one is then used to initialize our variable a1. And again, what happens then? Again, like all time, it jumps here to the a1 type and and it says, oh, you are again an L value. I mean, here it is an R value. From here to here we have an R value because it's this temporary value. So an R value is again calling our move constructor like before, and so we have here the third step calling the move constructor and we creating a1. So that was just a little bit so conceptual, and in real this will not all time happen. So the question is why? Because there are some optimizations. One famous optimization is here, this one here, when you have a function and if you have a name, for example, this is a named variable, then there is a so-called named value, named return value optimization, or if this is not a name, just a PR value, it is called just return value optimization. So here, this LVO can happen. So there is this return value optimization, but when you have a N, this one is the compiler doing. And this return value optimization is doing just say, the compiler say, I will not create a return value. I mean an object. So this hidden object here, this for the function. So normally the function returns here, and then it is creating this result object here, what we just created here. But if this optimization is on, it says, no, I'm not creating this one. I don't need it. And then we have a problem because we have used here this result object to initialize A, but this is also not possible. So the compiler said, don't worry, I don't need call this one as well. So instead, what the compiler is doing with this optimization, and this optimization works only in this case with initialization. That's very important. It works not with normal assignment in this case. So this one works only with initialization. Then with the compiler says, when I create this A here, I have this A here, I will create it directly, and that sounds a little bit strange, directly here in A1, and will skip this part and this part. So it is anyhow jumping from here and creates it here. So it is skipping this both steps here. It's skipping this and is skipping this one as well and creating here. But this is this special case with this optimization, and if the compiler can do this, it will do this, and this will give again a lot of boost, because now we have the slow L value here. You can see we had this slow L value. This is skipped, but here also the move constructor call from here and here is skipped, and this becomes very fast. And sometimes there are even other optimization. I show you one more time fast. For example, that's also a little bit hard, but anyway, for example, the compiler can here, for example, I said this one here is an L value, right? But in this case it's a special case, and there are special rules, and one rule says, if the compiler sees here an L value and the type, the return type, has a move constructor, it can even treat this L value as an R value. And this can happen, for example, if this NLV oh, it's not possible to optimize, it can fall back to this optimization. So that's a little bit strange, because this L value is then treated as an R value, and R value means it can call here instead the slow copy constructor, which we called the fast move constructor again. But these are very special rules, optimization rules. I want to just show you this kind of stuff, that you get not irritated with the concept what I showed you at start. This is just more a concept. So let's say this is the normal, would be the normal flow, but nobody is using it because optimization has higher priority. If possible, use optimization. If not, use not. So with that said, I stop here this video. In the next video, we will continue here with this one and run this a little code snippet here and this one here. And if you have any questions, like all time, write in the comment section. See you in the next video. Bye and good luck.